So this video deals with simplifying rational expressions. First of all, to simplify rational expressions, we factor both the numerator and the denominator. Then after that, we use the cancellation property of fractions. So basically that means this. If given the rational expression that has all these factors in the numerator, it has all these factors in the denominator, what the cancellation property of fractions means is this. Basically, having this x divided by that x, we can cancel both those out. X divided by x leaves you 1 over 1. That's what they reduce to be. And then we look for any other factors that are common in the numerator and denominator. If you notice, we have a subtract 1 and a subtract 1. X subtract 1 here. They also cancel, and they reduce to be 1 over 1. And I have an x plus 7 and x plus 7. They both also cancel to be 1. So what I have left on top is a 1 times x plus 2 times 1. And on the bottom I have 1 times x plus 3 times 1 times 1. Now truthfully, if you saw 1 times 1 times 1, you know that that's just going to be 1. So it's going to be 1 times x plus 2. So my numerator is simply x plus 2. My denominator is 1 times all those 1s is still 1. So my denominator is just x plus 3. So my final answer is x plus 2 divided by x plus 3. The reason why I can't simplify this any further is, like some students look at this and say, well, can't I just take this x and divide it in each one of those? But you really can't. This x is added to 3, so they're forever stuck together. Same case with this 2. It's been added to x, so they're forever stuck together. The only way you can cancel it is if you have an x plus 7 and another x plus 7. But you can't take this piece and that piece and cross simplify and so forth. It just doesn't work that way. If you had to write this fraction any other way, this is a simplified answer. But if you had to write that fraction any other way, it could look like this. So if you were given x plus 2 all over x plus 3, you can't simplify it any further, but you can write it differently. If you're going to divide this into it, the numerator, you can only divide into each part of the numerator, each term of the numerator. So every term is separated by addition or subtraction. So I could rewrite this as x divided by x plus 3 plus 2 divided by x plus 3. That's perfectly fine. This is true. If I expanded this, x plus 2 over x plus 3, each of these numerators, each term in the numerator, all have to be divided by x plus 3. You wind up getting this. Now this doesn't simplify any further either. So this is what it is. So even though this is a fine answer, it can be represented in other ways. It can be represented this way as well. What you already know is by adding fractions is if they have the same denominator, you can add the numerators. So if you add the numerators, you get x plus 2 as a numerator all over the denominator, which is x plus 3, which is exactly what we began with. All right, so if you want that as a note, I copied that. I'm about to leave the screen though. Okay, so we got a new example. So simplify the expression x squared subtract 1 over x squared plus x subtract 2. We want to simplify this. You want to factor numerator, factor denominator, and also see if we have any factors in common that we can cancel out. So in the numerator for this problem, you should recognize that factor to be x plus 1 times x subtract 1. The denominator should also see that really factors as well, to be x plus 2 times x subtract 1. So if you actually factor each of those, you should come up with these factors. And you should look for the common factors, the ones that they both have in common in the numerator and denominator. So one of the factors in the numerator is x subtract 1, one of the denominator is x subtract 1. We should recognize the cancel to be 1. So that's 1 over 1. So the only thing we have left is x plus 1 times 1, which is just x plus 1, all over x plus 2 times 1, which is just x plus 2. So our final answer for that one is x plus 1 all over x plus 2. So I'm going to create another one for you to try. Write down this example and then simplify the expression 3x subtract 9 divided by x squared subtract 9. So pause the video, write it down, try it on your own. Good luck. So you should have recognized that the numerator factor to be 3 times x subtract 3 and the denominator factor to be x plus 3 times x subtract 3. So from there, I can cancel these, leaving me with yes, leaving me with just 3 divided by x plus 3. So if you need that as a note, I copy it down. If not, leave it in the screen too. When multiplying fractions, be sure to multiply numerator to numerator and denominator to denominator. You don't cross multiply in these. You multiply directly across. So what that means is this. The product of x over y times z over w, this is a z, is actually just x times z over y times w, or xz over yw. You don't have to have time symbols implied if they're right next to each other with no sign between them. That multiplication is happening. So that's what that means. So this is how it applies the problem we're working on. So simplify the expression below. This polynomial divided by this one times this polynomial divided by x subtract 1. So the first thing you should do is you're going to multiply all that stuff together. You can also look to see what these things actually factor to be before you go any further. For example, this factors and that factors. Numerator here factors to be x plus 3 times x subtract 1. The denominator there factors to be x plus 4 times x plus 4. On the other side, there's a 3 in common, so it factors to be 3 times x plus 4. And this is all over x subtract 1. So we multiply this, all this stuff gets multiplied together across the numerator. So this is now x plus 3 times x subtract 1 times 3 times x plus 4 divided by x plus 4 times x plus 4 times x subtract 1. And you want to look for what you can cancel out. So if you look at this, you may notice that I have x subtract 1 here and x subtract 1 there. So they can cancel. So in a new line, I'll rewrite. So I'm going to rewrite it up here in green. Just so if you're taking notes on it, you have a good note. You have to write over on top of stuff. It has a logical progression. So this would follow to here. And we're going to look for like terms. So this one cancels there to be 1 over 1. And I have x subtract 1 on top and bottom. They cancel to 1 over 1. There's nothing else is in common. There's also on top and bottom. So my only answer now is x plus 3 times 3 all over x plus 4. You may see this multiply together. You don't have to. But you may see it as 3x plus 9. I'm not going to bother. I like to leave it factored. So I'm going to call this 3 times x plus 3 all over x plus 4. By leaving it in the factored form, you can more easily see the zeros, the x-intercepts, y-intercepts, all sorts of things. So I'm going to leave it in the factored form. So that's it. That's how it works if you multiply rational expressions. So when dividing rational expressions, so in this case, instead of multiplying, we're going to divide them. When dividing rational expressions, we use the division property as it relates to fractions. So you may remember copy, change, flip, or keep, change, flip, however your 5th grade teacher might have told you how to divide fractions. But it all comes back in these examples. So for example, if given w divided by x divided by y divided by z, then that's equal to the product above w divided by x times the reciprocal of y over z. So reciprocal of that is z over y. So we just learned last few minutes ago that in order to multiply those, you simply multiply the numerators. So w times z all over x times y. So just know this. You're going to keep the first one the same, change the sign of multiplication, flip the fraction. You learned in 5th grade, probably did 6th, 7th, 8th, 9th, and now 10th grade. But it's one of those things that we should have some kind of experience with. You know, flipping, getting a reciprocal, whatever. As a matter of fact, you probably heard the word reciprocal the first time you learned to do this method of multiplication or division. So yes, it's very useful and it still comes back. Even though it comes from elementary school, we use it in this classroom all the time. Okay, so given this example, you want to divide this polynomial divided by these two polynomials. So basically you're going to first keep the first one the same, x subtract 4 all over x squared subtract 4. And truthfully, you can pause the video and try this on your own. You should be able to handle it. But you're going to multiply by the reciprocal of this, which is x squared plus 5x plus 6 divided by x squared subtract 3x subtract 4. So what you're going to look to do is you're going to look to see if you can factor any of that stuff and then start multiplying. I'll generally do that first. So you may recognize a lot of this stuff factors. The top is x subtract 4. The bottom there gives you x plus 2 times x subtract 2. I'm multiplying this, so I may as well go and factor this and multiply them together. So it's going to be times the factors of those. That factors would be x plus 3 times x plus 2. And the bottom here factors to be x subtract 4 times x plus 1. And then from there you're going to look for what cancels. So I'm going to rewrite it again and help look for and find what cancels. So in the numerator, you may recognize both these x plus 2's cancel to be 1 and 1. And I don't see anything else that cancels. Oh, well, I do see this x subtract 4. They also cancel. And now I'm seeing anything left. So we have a numerator is x plus 3. And that's going to be divided by x subtract 2 times x plus 1. You can fold that together if you want. I don't see the purpose in that. I'm leaving it there. That would be the final answer for it. And we divided it. Okay, last type of example. In order to add or subtract fractions, you must have the exact same denominators. So to have the same denominators, we can't add them or subtract them. So for example, simplify the rational expressions by addition or subtraction. So given these two, we want to simplify them. The rule is they have to have the same denominator. These already have the same denominator. So there's not much to do. So since they have the same denominator, we can simply add them right across the numerators. So this is going to equal to 2 plus d. And we add them. We don't change the denominators. They stay the same over 3d. So this is now simplified. It's been condensed to be 2 plus d divided by 3d. Now in the case of the second example, they don't have the same denominators. Since they don't have the same denominators, there's more to it than just like adding 3 to the bottom there and make them have the same. Everything has to be balanced. So whatever you do to one side of the equation or one part of the expression, you must do to the other. So basically what you want to do is you want to multiply this equation and that, or this expression or this term by something and this term by something else so that they both have the exact same denominators. Sometimes you don't have to multiply them both by a number. Sometimes you just have to manipulate one of the terms. In this case, you have to manipulate both of the terms. So I'm going to take the first term, 3, all over x subtract 1. I'm going to multiply it by the part that it doesn't have, which is x plus 2. So multiply by x plus 2 over x plus 2. By doing that, x plus 2 over itself is equivalent to 1. So if I multiply anything by 1, I don't change it. So when I multiply by x plus 2 divided by x plus 2, it only gives the problem a cosmetic change, not a real change at all, because it's the same problem. I'm multiplying it by 1. In the second part, I'm going to make it have the same denominator by taking this piece and multiplying it by the term it doesn't have, which is x subtract, well, the binomial it doesn't have, which is x subtract 1. Let's multiply top and bottom by x subtract 1, which is also my unit multiplier, which is equal to 1, so I can do that. So my numerator here is now 3x plus 6 all over x subtract 1 times x plus 2. On the second part, my numerator is now x squared subtract x all over x plus 2 times x subtract 1. What's great about this is they both have the same denominators now, so I can add them. And when I add them, I should wind up having 3x and negative x gives me 2x when I add this. So I wind up having this as my new polynomial. This looks like something that's factorable, so I would check and see if I can factor it. You really can't, because you can't get 2 numbers multiplied by 6 and add by 2. So this is our final answer as far as it goes. So that's pretty much all I have to tell you. Good luck.